Good morning, ma'am.
Yeah, good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, children. Good evening.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. Yes, children, we are continuing with squares and square roots. So this question, what is the least number to be added to 15,130 to make it a perfect square? What is the smallest number to be added to 15,130? So 15,130 is not a perfect square. It is not a perfect square. Now, for example, 75 is not a perfect square. 75 is not a perfect square. So the smallest number that is to be added to 75 to make it a perfect square is 6. Because we know that after the perfect square after 75, that follows 75 is 81. If you have to answer this question, what is the smallest number that is to be added to 75 to make it a perfect square? 75 is not a perfect square. What is the smallest number that is to be added to 75 to make 75 a perfect square? So the answer is 6. Because when you add 6 to 75, the sum is 81 and 81 is a perfect square. But this we cannot guess. When the number is large, you cannot guess. Now tell me, what is the smallest number to be added to 120 to make it a perfect square? What is the smallest number to be added to 120 to make it a perfect square?
1.
1. 1 is the smallest number. Good.
22.
22, is it?
Ma'am, because 144 is a perfect square.
Okay, but that's not the smallest number. Not 22 then, 24. Nandana.
Okay.
Okay, so Nandana, you said 24, correct? You can add 24. You can add 24 to 120 and make it a perfect square, 144. That's correct. But the question is, what is the smallest number? What is the smallest number? So the smallest number is 1. Because when you add 1 to 120, you get 121.
Yes, 121 is a perfect square.
Yeah, and 11 into 11 is 121. So the smallest number is 1. You can also add 24 to 120, but 24 is not the smallest number. 1 is the smallest number that is to be added to 120 to make it a perfect square. So the resultant number is 121. When you add 1 to 120, the resultant number is 121 and 121 is a perfect square. So this is such a question. So you have to find the smallest number that is to be added to 15130 to make the perfect square. Now, children, to find the least number to be added or subtracted, you should use the long division method. To find the least number, remember, listen carefully, to find the least number to be added or subtracted, whatever, added or subtracted, you should use the long division method. You should use the long division method. Now, all of you find the square root of this number, the given number using long division. It's not a perfect square. You will not get remainder 0. You will not get 0 remainder. But perform the long division and tell me the remainder. You will not get 0 remainder. You will get some non-zero remainder. You will get some remainder other than 0. Yes, perform the long division. Take down the question. Take down the question and perform the long division. Yes.
Ma'am, should we keep decimal point or we can stop?
No. Yeah, good question. No. Don't. You just use only these digits. You don't have to add zeros after the decimal point.
Yes, ma'am. Ma'am, I got the answer.
Yeah, what's the remainder you got?
1, ma'am.
1 is the remainder. Okay. One is the remainder. All right. So what's the number you got right on top here? What's the number you got right on top here?
1, 2, 3.
1, 2, 3. 1, 2, 3. Correct? And you got
Yes,
remainder
ma'am.
1.
Yes, ma'am.
Okay. Friends, have you finished? Are we all getting the same thing?
Last step I did, ma'am.
Okay. Yes, time up. Harshita and Ritika?
Ma'am, yes, ma'am. I'm getting the same answer.
Ritika?
Ma'am?
Yeah. Are you performing the long division?
Yes, ma'am.
Okay, but it's time to see the answer, children. Yes. Those who got 1, 2, 3 right on top and 1 is the remainder. You're right.
Ma'am, I got 1, 2, 3.
Yeah. So you can see here, you'll have to first group the digits. You'll have to first group the digits in this direction. So 3, 0 makes a pair. 5, 1 makes a pair. 1 stands alone. 1 stands alone. From right to left, you'll have to pair backwards. From right to left, backwards. So then 1 stands alone. 1 ones are 1. 1 ones are 1. The next thing you can do is 2 twos are 4. 2 twos are 4. But 4 is greater than 1. What we have here is 1. So we start with 1 ones are 1, 1s are 1. And 0 is the remainder. The next pair comes down. The next pair 5, 1 comes down. Double the quotient. Double the quotient. 1 into 2, 2. Write that here. Then the next digit will be whatever you place here, you must place the same digit here. So now if you add 1 here, it will be 21 into 1. You will get 21. You will get 21. 22 into 2 will give you 44. And you have 51 here. You have 51 here. So 22 into 2. The next will be 23 into 3. The next will be 23 into 3. 23 into 3. That will become 69, which is greater than 51. So you have to write a 2 here. You'll have to write a 2 here and a 2 here. So 22 into 2 is 44. Remainder 7. Bring the next pair down. 3, 0 comes down. We have 12 here right on top. Double it, 24. So write 24 here. And since it's not a perfect square, you will not get 0 as a remainder. So you will not get this number 730. You will not get this number 730. You should look for a number just less than 730. You have 24 here. So 243 into 3. 243 into 3 is 729. Place a 3 here and a 3 here. So that is 243. 243 into 3 is 729. And 1 is a remainder. 242 into 2 will be very less than 729. Supposing you write a 2 here and a 2 here. 242 into 2. 242 into 2. 484. 484. That's very less than 730. You should try the next one. So 243 into 3, which is 729. You try 244 into 4, 244 into 4, that will be bigger than 730. That will be greater than 730. So 729 is the precise number, which is 243 into 3. 1 is the remainder. Now, take the successor of the quotient. With the number you have right on top is 123. Take the successor, that is the number that comes just after 123. The number that comes just after 123, that is the successor of 123 is 124. Square it. Find 124 square. Find 124 square. That is find. You should multiply 124 into 124. You should multiply and find the product. It's 15,376. Now, this number, this product which you've got, 15,376 minus the given number, minus the given number. This is what is 124 into 124 minus the given number, 15. Oh, I made a mistake while typing here.
It is 31, you know, it is 29.
Yeah, that's what. I made a mistake
still
while
have
typing.
that's why I have a doubt on it.
Sorry. I made a mistake while typing, children. I don't know how I typed 15129. I'm sorry. This is actually 15130. Sorry. Okay. So 124 square minus the given number, 15130 is 246. Is 246. That is the least number. 246 is the least number to be added to 15,130 to make 15,130, meaning to make that result so that the resultant number is a perfect square. That is 15130, the given number 15130. You must add 246 to this. So the resultant number, the new number is, so you will get this one. You will get this number. So that is 7351. You'll get this number. And this number is a perfect square. What is the square root of 15,376? What is the square root of 15,376?
124, ma'am.
Yeah, 124. 124. You can see it on the screen. It's 124. This is the procedure, children. This alone I've made a mistake. This is 15130. Yes, please take down the answer.
Ma'am, but the answer is same.
Yeah. The difference I've written correctly while typing. I don't know how I put 15129. Made a mistake in typing. Yeah. So this is the procedure to find the least number to be added to the given number to make it a perfect square. See, 15130 will not become a perfect square. 15130 is an imperfect square. When you add 246 to 15130, you get a new number. That new number is a perfect square. The given number 15,130 cannot be made a perfect square. That is an imperfect square. When you add 246 to 15,130, that new number is a perfect square. So this is the procedure to find the least number to be added. To find the least number to be added, we need to use the long division method. Use the long division method. And then you must take the successor. Once you finish the long division, take the successor of the quotient obtained. So the quotient is 123. The successor of 123 is 124. Find the square of 124. That is, find 124 into 124. And it is 15,376. Now this number which we get, 15,376 minus the given number, 15,130, gives us 246. And this is the smallest number to be added to the given number to make it a perfect square. So remember this procedure. Done, all of you?
Yeah, ma'am, done. Completed. Yes, ma'am. Thank you.
All of you? Ritika?
Yes, ma'am.
Okay. Harshita, Bhavishya?
Yes, ma'am.
Swati and Nandana? Done?
Yes, ma'am.
I'll let you do. What is the least number to be subtracted from 77,000 to make it a perfect square? What is the least number to be subtracted from 77,000 to make it a perfect square? Now tell me, what is the smallest number to be subtracted from 75? What is the smallest number to be subtracted from 75 to make it a perfect square, class?
Is it 11?
Yeah, 11. 11. Because where does 75 lie? Where does it lie? It lies between 8 square, 64, 9 square, 81. So it's in between 60. It's in between the perfect squares 64 and 81. 75 lies between the two perfect squares 64 and 81. The number 75 lies between the perfect squares 64 and 81. 8 into 8 is 64, 9 into 9 is 81, and 75 is here. So the smallest number to be added to make it a perfect square is 6. And the smallest number that is to be subtracted from 75 to make it a perfect square is 11. It becomes 64, and 64 is a perfect square. The smallest number to be added is 6. The smallest number to be subtracted is 11. Now tell me, what is the smallest number that is to be subtracted from 53 to make it a perfect square? What is the smallest number that is to be subtracted from 53 to make it a perfect square?
I'm 4.
4. So where does 53 lie? It lies between the perfect squares 49 and 64. 7 square is 49, 8 square is 64. So 53 lies between the perfect squares 49 and 64. 7 sevens are 49, 8 eights are 64. 53 lies between the perfect squares 49 and 64. So the smallest number that is to be subtracted from 53 to make it a perfect square is 4. When you subtract 4, you get 49, and 49 is a perfect square. What is the smallest number to be added to 53 to make it a perfect square?
I'm 11.
11. 11. So when you add 11, it becomes 64, and 64 is a perfect square. Are we all following?
Yes, ma'am.
Okay, now when we have to deal with larger numbers, there should be a procedure. We cannot do this method. When the numbers are very small, then you can adopt this procedure. But for larger numbers, you need a different procedure. So here also, I told you to find the least number to be added or subtracted, you should use the long division method. Register that in your mind. To find the least number to be added or subtracted, you must use the long division method. Now here, whatever is the remainder should be subtracted. Oh, I shouldn't show you the long division. Whatever is the remainder should be subtracted. So use the long division method and find the square root of 77,000. It's not a perfect square. You will get some remainder. Or supposing you get 3 as a remainder, supposing. Then 3 is the smallest number to be subtracted. Whatever is a remainder should be subtracted. For subtracted, the procedure is whatever is a remainder that should be subtracted. Just do the long division, all of you. Whatever is a remainder should be subtracted.
Ma'am,
Yeah.
ma'am, I am getting the remainder 14,839, ma'am.
No. You cannot get such a large remainder. No.
I 271 was the remainder.
271. Let's ask Bhavishya what she did. Bhavishya, read out your steps.
Yes, ma'am. Ma'am,
Yeah.
first, ma'am, 7,07,000 they gave, ma'am. So I have
7,07,000, huh? 77,000.
Okay, ma'am. 77,000 they gave, ma'am. So
Yeah.
I have grouped the 2 zeros and 70 and 17, ma'am. So I have taken 2 twos of 4, ma'am.
Correct.
So I got the remainder 3. So after that I have done that. I have bring that 70 down, ma'am. So I got 370, ma'am. 2 into 2, like I have got 4, ma'am.
Yes, you're right so far. Then
Now after that I have done 47 into 7, ma'am. So I got the 329, ma'am.
7 sevens are 49, 4 carry over. 7 fours are 28, 32. 329. 329. What is 48 into 8? 8 8 are 64, 4 6 carry over. 8 fours are 32. 32 and 6 is 38. Yeah, it is more than 370. So you're right. 47 into 7. Yeah.
After that I have got the remainder as 41, ma'am. I have bring that 0 down, and after that I have multiplied that 27 into 2, ma'am. So I got 54. After that I have multiplied into 54. 546 into 6, I have got 3,276, ma'am. So I have done
Second,
that.
second 6 6 are 36, 3 carry over. 6 4s are 24, 27, 2 carry over. 6 5 are 30, 32. Okay. So 546 into 6 is 3,276. What's the remainder?
Ma'am, after that I have done by 7, ma'am. I haven't done by 6, ma'am.
Oh, I didn't check 7. 547 into 7.
I got
Okay.
that 3,821, ma'am.
I didn't check 7. Sorry. 7 7 the 49 9. 4 carry over. 7 for the 28 32 2. 3 carry over.
I got
Yeah, 7 5 are 35 38. No, oh, yeah. It's 7, not 6.
271, ma'am.
1 minute. 1 minute. So this will not work, but still we'll try. 8 is the 64, 6 carry over. 8 for the 32, 38, 3 carry over. 8 for the 40, 43. Yeah. So it's 547 into 7. Yes.
271 is the remainder, ma'am.
Then you said something else.
Ma'am, first I have done mistake in that second step, ma'am. I have wrote like 166 Once first step I have done that I have grouped that first two months that 77 like that I have done.
Okay, fine. Okay, class. So whatever is the remainder is to be subtracted. What is the remainder? The remainder is 271. The remainder is 271. Whatever is the remainder, that is to be subtracted. So 271 is the least number to be subtracted from 77,000 to make it a perfect square. We can also check it. We can also check that. So when you subtract 77,000 minus 271, so 92777, and find the square root of this number.
I'm the quotient, ma'am, 277.
Yeah. Whatever is the quotient will be the answer. You can check 277. Find the square root in the rough column, all of you.
Now, only when they ask to be added from a number, we need to find the successor and then we need to subtract it. Whenever subtracted, we need to just subtract the remainder from the number given.
Yes, correct. Correct.
Yes, ma'am.
So you can check. This number will be a perfect square.
Ma'am, I got the square root as 277, ma'am.
Yeah, you're right. With zero remainder, right?
Ma'am,
Yes,
the
ma'am.
next we need to find the 278 square. We need to find the answer.
That is to find the least number to be added.
Subtract it. So we should find the predecessor. Like
No. This is the procedure. What you've understood now is the procedure. What I just told you is the procedure. No predecessor and all that. For subtracted, whatever is the remainder, that is to be subtracted.
Yes, ma'am.
All right. All of you finished?
Yeah, ma'am, done.
Done, ma'am.
done, ma'am.
Ritika?
Ma'am.
Okay. Ritika, what is the procedure to find the least number to be added?
For
To the,
number, ma'am.
what is the procedure to find the least number to be added to make the given number a perfect square?
Ma'am, we should first find the a square of not a square.
Should perform the long division or prime factorization method?
Long division method, ma'am.
Long division. We should perform the long division. Then?
Ma'am, then we should take the successor of the quotient and we should find its square, ma'am.
Okay.
And then we should subtract the given number from the square of the
Successor.
yes, ma'am.
Correct. Very good.
We should
So when you subtract, whatever is the remainder, that number is to be subtracted, right?
yes, ma'am.
Okay, very good. And the procedure to find the least number to be subtracted?
Ma'am, we should first the given number we should do it in the long division method, ma'am, and
Okay.
the remainder is the least number to be subtracted, ma'am.
Very good. Very good. Okay. So the next question, which is the greatest 6-digit number that is a perfect square? Write down the question, children.
A similar type of question was asked in a test.
Oh, your test, is it?
Yes, ma'am.
Okay, okay.
I mean the test you have conducted.
Oh, okay. No, but this question I wouldn't have asked, no, because we are learning it only in this lesson plan.
A similar type of question, I think you asked 4-digit largest number that is a perfect square.
Okay, okay. Okay. Write the question, children. Yeah. And see the procedure. So to find the greatest 6-digit number that's a perfect square, you must make use of the greatest 6-digit number. You must make use of the greatest 6-digit number. To find the greatest 6-digit number that's a perfect square, you will have to make use of the greatest 6-digit number. So 9,99,999 is the greatest 6-digit number. Perform the long division. Perform the long division. Whatever is the remainder, subtract it from the greatest 6-digit number. The resultant number is the greatest 6-digit number that is a perfect square. You can understand from the procedure, children. Don't copy the long division. Please do this by yourself. Perform the long division by yourself. Do the calculation in the rough column. Use the greatest 6-digit number. Perform the long division. Done, children?
Please wait, ma'am.
No, ma'am, not. I also got the same answer.
No, ma'am, please wait, ma'am. Doing.
Yeah.
Done, ma'am.
Yes, done, children?
Yes, ma'am, got the answer.
Yeah, ma'am. Done.
Okay, so
Yes, ma'am,
what is the
done, ma'am.
question? All right, so the question is, which is the greatest 6-digit number that is a perfect square? So since you'll have to find the greatest 6-digit number that's a perfect square, you'll have to make use of the greatest 6-digit number. This is the greatest 6-digit number. Use that number and perform the long division. Remember, to answer these questions, to answer such questions, you'll have to use a long division method. You should remember the procedure. If you do the prime factorization method, you cannot get it. To find the least number to be multiplied or divided, you should use the prime factorization method. To find, see, because here you will have find the least number to be added to make something, or to make the given number a perfect square. Find the least number to be subtracted to make the given number a perfect square. Then find the least number to be multiplied. Find the least number to be divided. Which is the greatest 6-digit number? Which is the least 6-digit number? You will have questions of, these kinds. What is the least number to be added? What is the least number to be subtracted? What is the least number to be multiplied? What is the least number to be divided? For this one, multiplication and division, that is, what is the least number by which it should be multiplied? What is the least number by which it should be divided? For that, you should use a prime factorization method. Prime factorization method. Multiplied and divided, you should use the prime factorization method. What is the least number to be added? Long division method. What is the least number to be subtracted? Long division method. Which is the greatest 6-digit number, or which is the least 6-digit number for all this prior long division method? For multiplied and divided, prime factorization method. Multiplied, divided, prime factorization method. Got it, children? All of you understand?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
What is the least
Yes, ma'am.
number by which it should be multiplied, or what is the least number by which it should be divided? You should use the prime factorization method. What is the least number to be added, subtracted? Long division method. Which is the greatest 6-digit number that's a perfect square? Which is the least 6-digit number that's a perfect square? For such questions, long division method. Long division method. So remember this. The procedure is important. Then you know how to carry it out. But if you're confused, Should I use the long division method or the prime factorization method? If you're confused there, nobody can help you. You must remember that. Which method to use? For what kind of question? Which method to use? When to use prime factorization method? When to use a long division method? That you must remember. I told you now, no? Remember that. So here to find the greatest number, greatest 6-digit number. So perform the long division like this. Perform the long division, you get some remainder, right? So this number, whatever number we have taken up, minus the remainder, you get a new number. You get a new number. Whatever number we have taken up, that is this number, minus the remainder. You get a new number. That new number is the greatest 6-digit number. That is a perfect square. See, the greatest 6-digit number is this one only. This is the greatest 6-digit number, but it's not a perfect square. This is the greatest 6-digit number, but it is not a perfect square. We have to find the greatest. There are two conditions here. It should be a 6-digit number and it should also be a perfect square. There are two conditions. So when we were in third or fourth, we know only this. Which is the greatest 6-digit number? Only one condition there. Which is the greatest 6-digit number? 9,99,999. Now there's an additional condition. Which is the greatest 6-digit number? That is a perfect square. So it should be a 6-digit number, and that 6-digit number should also be a perfect square. Two conditions. So make use of the greatest 6-digit number, perform the long division, you get a remainder. So find the difference. Find the difference, you get a new number. That new number will be the greatest 6-digit number, which is a perfect square. Got the procedure? No doubts?
Yes, ma'am.
Yeah. Next. Which is the least 6-digit number? That's a perfect square. Which is the least 6-digit number? That is a perfect square. So for this,
we put 1 and 5 zeros.
yeah.
And we'll put 1 and 5 zeros.
I don't know what you're asking. Who's asking me? Who's talking to me? Okay. Yes, children. So which is the least 6-digit number? That is a perfect square. So for this, we need to make use of the least 6-digit number. Which is the least 6-digit number? Which is the least 6-digit number?
1 and 5 zeros, ma'am.
1 and 5 zeros. 1 followed by 5 zeros. 1, 2, 3, 4, 5. Yes. So which is 1 lakh. Now perform the long division method. Use this number, perform the long division method, and tell me when you're ready.
Shall I say what I got?
Yes.
Ma'am, I got the quotient as 316 and the remainder as 144, ma'am.
Okay, 316.
Yes, ma'am.
And the remainder is
144.
144.
Same answer.
Okay,
I too got the same answer.
all right. Yeah, correct. So now this one is just for you to check. You don't have to actually show this, but I've just written that here. This one is just for your reference. You can even ignore that. So if you look at this, take up the quotient you've got and square it and square it. So that is find 316 into 316. You'll have to multiply. Find 316 into 316, this number. You will see that this number is a perfect square because it is 316 into 316. It's a perfect square, but it is a 5-digit number. You can see it here, 99,856. We are supposed to find the least 6-digit number, smallest 6-digit number. But this one is a 5-digit number. So that means this is not working. 316 square is not working. So we'll take the successor of 316, which is 317. Which is 317. We'll take the successor of this one, 317. Multiply 317 with itself, you will get 1,489. And that is the smallest 6-digit number, which is a perfect square. This is just for you to understand. If you take the quotient and square it, since you are squaring it, it is a square number. But it's a 5-digit number. So this will not work. You should take the successor of the quotient, 317, square it, you get an answer. And that is the smallest 6-digit number. That's a perfect square. Completed, children? Need not show this.
Completed, ma'am.
Yeah, my division is correct, no?
Yes, ma'am.
Yes, ma'am.
Okay. Here also my division was right, no? Oh, I just want to check if I went wrong in typing anywhere. So please check this also for me.
No mistake, ma'am.
Okay, thank you. So far we have seen, the smallest number to be added, the smallest number to be subtracted, then the greatest 4-digit, 5-digit, or what we saw now is the greatest, find the greatest 6-digit number. That's a perfect square. And this one is find the least 6-digit number. That's a perfect square. Four sums, all 4 different types. Finish, children?
Done, ma'am.
Done, ma'am.
Okay. So next class, you will be taking up a test based on these questions. All right?
Yes, ma'am.
Yes, ma'am.
Yeah. Yeah. Take the first question.
Should I say how to do it because I found a similar sum in my book?
Maybe you can work and give me the answer.
Yes, ma'am.
Yeah.
Ma'am, can I use the restroom, ma'am?
Yeah, please. Supposing you have supposing you have 9 chairs. Supposing you have 9 chairs. How will you arrange it in equal number of rows and columns? So you will make 1, 2, 3, 1, 2, 3, 1, 2, 3. Yes.
Yes, ma'am.
Okay. So supposing we have 9 chairs and you have to arrange it in equal number of rows and columns. So see here, 3 rows, 1, 2, 3, 3 rows and 3 columns, 1, 2, 3, 3 columns. So we have arranged 9 chairs in 3 rows and 3 columns. In 3 rows, first row, second row, third row. 1, 2, 3 rows and 3 columns. 1, 2, 3 columns. So supposing you have 16 chairs. 16 chairs. And you need to arrange 16 chairs in
4 columns and 4 rows.
4 columns.
Yeah. So supposing you have 16 chairs and you have to arrange them in equal number of rows and columns. You will make 4 rows. First row, second row, third row, fourth row. You will make 4 rows and 4 columns. You will arrange the 16 chairs in 4 rows and 4 columns. So that means what should you do with this number? If you have to arrange 11,236 chairs in equal number of rows and columns, how will you get the answer?
And we need to find the square root of the given number.
You should find the square root of the given number. That's all. It's so simple. You just have to find the square root of the given number.
Ma'am, shall I say what I got?
Yes.
Ma'am, I got 106 as the square root, ma'am.
Okay, 106. So that means you will have to make 106. You have to arrange the chairs in 106 rows and 106 columns.
Yes, ma'am.
Correct. Are you there, Mritika?
Yes, ma'am.
Bhavishya?
Yes, ma'am. And the answer is 106.
The answer is?
106.
Okay. Yes, 106. Very good. So the question is in how many? Find the number of rows in which the chairs are arranged. Therefore, the chairs are arranged in 106 rows. The chairs are arranged in 106 rows. Ritika, you were not sure about the long division, right? Any help here?
No, ma'am. Clear, ma'am.
Okay, so tell me. Yeah, please tell me, explain the procedure.
Ma'am, should I explain the log division method?
Yeah.
Ma'am, when we take 1, 2, 3, 6, 1, we should first pair the numbers, ma'am. We should when we pair, 1 will be left out, ma'am. So 1 ones are 1, ma'am, and now the remainder is 0, and now we should take 12 down, and so as we take 12 down, for ma'am, it's a bit confusing.
Double the quotient.
No, ma'am,
Double the-
I have a doubt at the 0.
Yeah. Oh, what? Now tell me, how did I get 2 here?
Ma'am,
How did I get 2 here?
when we double the add the quotient, ma'am.
Okay, double the quotient. 1 into 2. 2.
Yes, ma'am.
Now, whatever digit you place here, whatever digit
Yes, ma'am.
is here, you must place the same digit here.
Yes,
Now,
ma'am.
supposing I write 1 here and 1 here.
Yes, ma'am.
Yeah, what will it give me?
21. Ones are 21. 21, ma'am.
21 into what?
21 into 1, ma'am.
21 into 1. It's 21. Correct?
Yes, ma'am.
But what is the number here?
12.
12. It's less than 21, right?
Yes, ma'am.
So we can't add 1. We cannot. 1 is the smallest digit. That itself is too much now. 21 into 1 is 21. Is 21 and it's greater than 12. So what should you do? When 1 itself is, when you use 1, 21 into 1 is 21, which is greater than 12. So you cannot use 1. Then what is, which is that digit smaller than 1?
0.
0. 0. So add a 0 here. Add a 0 here. And bring the next number down. See, you can also do this. You can take one more extra step. You can add a 0 here and 0 here. Now, what is 20 into 0?
0, ma'am.
0. So 0. 20 into 0. 20 into 0, right? 20
Yes,
into 0 is 0. So 12 is the remainder now. Now 12 is the remainder, right?
Yes, ma'am.
Bring the next pair down. 3, 6. Double the quotient. 10 into 2. 20. Okay.
Yes, ma'am.
Now, whatever digit you place here, you must place the same digit here. And that is 6. 206 into 6, which is 1236. I've just given you one extra step. If you want to understand this one, is this understood? What I told you here? Have you understood this?
Yes, ma'am.
Now, when you add a 0, what you can do is, see here, we'll do it again from the beginning. 1, 1, 2, 3, 6. 1, 1s are 1. 0 is the remainder. The next pair comes down. Double the quotient, 2. When I add 1 here and 1 here, I get 21, but that's greater than 12. So what you do is add a 0 here, add a 0 here, and then bring the next pair down. add a 0 here, and add a 0 here, and then bring the next pair down. Now the number is 1, 2, 3, 6. Again, whatever digit you add here, you must place the same digit here. So 6 here and 6 here. 206 into 6 is 1236. Is it okay?
Yes,
Ritika?
ma'am. Yes, ma'am.
All right. So we just have to find the square root of the given number. So the chairs are arranged in 106 rows and 106 columns. Finished, all of you?
Yeah, ma'am, done.
Yeah, ma'am, done. Done, ma'am.
All right. 74,600 soldiers have to stand in rows and columns such that the number of rows is equal to the number of columns. Is it possible to do so? If no, how many soldiers would be left out? So now supposing there are 20 soldiers, all right? Supposing there are 20 soldiers. Can you arrange 20 soldiers in equal number of rows and columns?
No, ma'am.
No,
Ma'am.
because you can make 3 rows, 3 columns, 9 soldiers, 4 rows, 4 columns, 16 soldiers, 5 rows, 5 columns, 25 soldiers. But 25 is not possible because there are only 20 soldiers. Then you cannot make 5 rows and 5 columns because there are only 20 soldiers. So that means you have to make 4 rows and 4 columns. When you make 4 rows and 4 columns, you can accommodate only 16 soldiers. So 4 soldiers will be left out. 4 soldiers will be left out. So this is the situation in the given question, just that the number is large. Supposing 40 soldiers. There are 40 soldiers. There are 40 soldiers. You need to arrange 40 soldiers in equal number of rows and columns. 6 6 are 36. 7 7s are 49. So you have to use 6 rows and 6 columns. 6 rows. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. These are soldiers. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So like this, you make 6 rows. 1, 2, 3, 4, 5, 6 rows and 6 columns. 1, 2, 3, 4, 5, 6 columns. 6 columns. So when you make 6 rows and 6 columns, you can accommodate 36 soldiers. You can accommodate 36 soldiers. So 4 soldiers will be left out because there are 40 soldiers. When you make a square using 6 rows and 6 columns, you can accommodate only 6 6 are 36 soldiers. Then 4 soldiers will be left out. That means they cannot stand in this square here. You cannot accommodate them here. This is the situation we have in the question. Do we all understand?
Yes, ma'am.
Yes, ma'am.
Okay, follow the steps here. Do not blindly copy the long division.
Ma'am, I have done until 16,029, ma'am.
Children, I'll just come back. Please complete this answer. I'll just come back.
Yes, ma'am.
Completed this one, children?
Yeah, ma'am, done.
Yes, ma'am.
Alright.
Done, ma'am.
This long division, Ritika? Any doubts?
Ma'am? No, ma'am.
Is this long division clear for all of us?
Yeah, ma'am, clear. It's clear, ma'am.
Okay. Yeah. So whatever is a remainder, so many soldiers will be left out. So that means 74,600 soldiers will be arranged in 273 rows and 273 columns. 273 rows and 273 columns. And 71 soldiers will be left out. 71 soldiers will be left out. $74,600 soldiers. 74,600 soldiers will be arranged in 273 rows and 273 columns. Equal number of rows and columns. 273 rows and 273 columns. And 71 soldiers will be left out. All right. Yeah. Write the next question. ABCD is a square of side 15 centimeters. Find the length of the diagonal AC. Okay. Let's see the answer. So draw a rough diagram. ABCD is a square. So be careful when you mark it, okay? ABCD like this. That is when you mark, ABCD, you cannot mark A, B and C here, children. CD like this, you cannot mark. You cannot mark A, B, C, D like this. This is wrong. And or you cannot mark like this, A here, B here, C here, D here, like this, you cannot mark. You must go in the, when you mark the vertices, you must go in the clockwise or anti-clockwise direction. So if you start like A here and write B here, so A, B, then this is only C, then this is D. A, B, C, D. Going, so like this, meaning you're going in the anti-clockwise direction. Or if you start A here and B here, so A, B, so C here, then like that D. Okay. So I have marked A, B, C, D like this, A, B, C, D like this. Okay. A, B, C, D like this. And it's given that the side of the square is 15 centimeters. So I've marked 15 here. The side of the square is 15 centimeters. 15 centimeters. Find the length of the diagonal AC. We need to find the length of the diagonal AC. Now we know that in a square, every corner is a right angle. In a square, every corner is a right angle. So that means angle B is a right angle. Angle B is a right angle. So that means ABC is a right angled triangle. ABC is a right angled triangle. So in right triangle ABC, we use Pythagoras theorem. In right triangle ABC by Pythagoras theorem. So how do you apply Pythagoras theorem? Now this is the right angle. ABC is a right angled triangle. ABC is a right angled triangle. Now, why is AC the hypotenuse? Because it is the side opposite to the right angle. AC is the hypotenuse because it is the side opposite to the right angle. The side opposite to the right angle. This is the right angle. The side opposite to the right angle is called the hypotenuse. Hypotenuse. We are familiar with that term, right? Hypotenuse.
Yes, ma'am. The longest side in the right angle triangle.
Yeah, hypotenuse is the longest side in the right angle triangle. And that is the side opposite to the right angle. Okay, so square the hypotenuse. Square the hypotenuse. AC square. These are the remaining two sides. This one and this one. These are the remaining two sides. Square them and add. Square them and add them. So AB square, BC square. AB square. Square this side. Square this side. BC square and add them. AB square plus BC square. So the square on the hypotenuse is equal to the sum of the squares of the other two sides. That is the statement of Pythagoras theorem. Pythagoras theorem states that in a right angled triangle, Pythagoras theorem states that in a right angled triangle, the square of the hypotenuse is equal to, this is the square of the hypotenuse. This is the square of the hypotenuse is equal to the sum of the squares of the other two sides. Maybe you can just write down Pythagoras theorem. State Pythagoras theorem. State Pythagoras theorem. Write down, children. Pythagoras theorem states that in a right angled triangle, the square of the hypotenuse, is equal to the sum of the squares of the other two sides. Please write down, children.
Ma'am, in short, can we write that base square plus perpendicular square equals hypotenuse square?
Where for this one, huh?
Yes, ma'am.
Yeah. Some schools use that, yes. H square is equal to B square plus A square or something. I don't use this. Base square plus altitude square is equal to hypotenuse square. You take this as the base and this as
No,
the
ma'am, they're
altitude.
not right altitude. They're like perpendicular.
Perpendicular, whatever. Perpendicular, P square. So this is the base, this is the altitude, this is the hypotenuse. Hypotenuse square is equal to base square plus altitude square. Okay, fine. If your teacher says hypotenuse, this is the base, this is the perpendicular. If you're saying perpendicular or altitude, perpendicular. So hypotenuse square is equal to base square plus perpendicular square. Correct. Please write this statement, children. Written, all of you?
Yes, ma'am. Done.
Please wait, ma'am.
Yeah.
Done, ma'am.
Yeah, very good. All of you?
Yes, ma'am.
All right. So you can see it here. This is the square of the hypotenuse is equal to the sum of the squares of the other two sides. So AC square is equal to AB is 15. So 15 square plus BC is also 15, 15 square, because all the sides of the square measure 15 centimeters. In a square, all sides are equal. So 15 square is 225, 15 square is 225, 225 plus 225 is 450. So AC square is equal to 450. AC will be equal to the square root of 450. AC square is equal to 450. AC square is equal to 450. AC will be equal to the square root of 450. The square root of 450. We know that 450 is not a perfect square. 450 is not a perfect square. So find the express 450 as a product of its primes. You will get 2 into 3 square into 5 square. Please do this. When you do this prime factorization method, you will get 2 into 3 square into 5 square. So from 2 3s, 1 3 comes out. From 2 5s, 1 5 comes out. This 2 remains under the square root. So root 2. 2 remains under the square root. From 2 3s, 1 3 out. From 2 5s, 1 5 out. This 2 remains under the square root. That is why root 2. So 3 5s are 15. 15 root 2 centimeters. The length of the diagonal AC is equal to 15 root 2 centimeters. You must leave your answer like this. You must leave your answer like this. You should not stop here. Root 450, you should not stop here. So you can see 2 into 3 square into 5 square. Yes, complete this answer, children. Done, children?
Done, ma'am.
Others? Still writing?
No, ma'am. I have a doubt, ma'am.
Yes.
Why can't we add another 2 for 2, ma'am? We can multiply it on both the sides, ma'am, for 450 and for this.
Oh, I don't understand your doubt, Nandana. Where you can multiply to?
Ma'am, since 2 do not have the same exponent,
No, the question is not, okay, the question is not what is the least number to be multiplied. If the question is what is the least number to be multiplied, then 2 is the smallest number to be multiplied. That is not the question here. You cannot multiply like that. You cannot add something like that. Meaning you cannot introduce something new like that.
okay.
No. Finish, children?
Yes, ma'am.
Class, use the emoji. Raise your hand. Nandana, Swati, Bhavishya. Harshita? Okay. So we'll do this in the next class. How many more we have? Okay, maybe you can just complete these sums. We'll understand them in the next class. Please finish this, children. Take a screenshot. Complete this in your classwork. Please take a picture of this one. Work this in your classwork. We'll understand the procedure in the next class. Done, children?
Yes, ma'am.
Yes.
This one also. All right. So please complete 4 and 5. We'll understand the procedure in the next class. All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Good night, ma'am.
Thank you, children.
Right, ma'am. Thank you.
Thank you, children. Good night.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children.